Longitudinal joints, where two paving lanes meet, are one of the most important aspects in constructing long-lasting asphalt pavements. On airfields, joint performance is critical because deterioration can lead to cracking, raveling, water infiltration, and even dangerous foreign object debris.
Any debris on an airport runway is not good because you don't want anything being pulled into the engines and causing, catastrophic failures.
Because of those risks, the FAA currently requires paving crews to use the cutback joint method. The process involves trimming the edge of the first lane, applying tack coat, and then paving the next pass. While effective, researchers are exploring newer technologies that could deliver the same durability more efficiently.
The main challenge is getting adequate density on those joints, and that's really important in terms of making sure that the pavement is not going to allow water into that joint and that it will perform long term.
To continue advancing airfield pavement performance, the Airport Asphalt Pavement Technology Program, in partnership with the FAA and NAPA, evaluated innovative technologies that have already demonstrated success on roadway projects. Researchers studied technologies such as void-reducing asphalt membranes, known as VRAM, and rapid penetrating emulsions, or RPE. VRAM is applied before asphalt placement, creating a seal beneath the joint that helps protect it from the bottom up.
You place it down and it's a polymer modified asphalt. And what happens then is it not only holds the pavements together that you've just placed, but it also wants to pull up into that joint a little bit. So it's really increasing the bond strength of those two passes coming together.
RPE takes the opposite approach.
This product you put in after the fact, and it's a rapidly penetrating emulsion. So you would spray it on top of the joint and it would literally go down in and fill up some of those air voids and those pockets that were there. And again, would just help tie that longitudinal joint together.
Researchers also evaluated existing airfield projects and constructed new test sections to compare the different approaches side by side.
We built a few more projects just to compare VRAM longitudinal joints and cutback joints. And then we also evaluated rapid penetrating emulsion. So we'll follow those projects on some future research project.
Early inspections show promising results, including tighter joints, reduced permeability in some cases, and fewer signs of cracking. But researchers say additional monitoring is needed before recommending changes to FAA specifications.
I am excited. I think it's really important to keep some of these innovative technologies and techniques really on the forefront and be considering them and understanding what they can bring to the table for our pavements and for the airfield infrastructure.
As research continues, industry is evaluating new joint technologies that could extend pavement life, reduce maintenance, and enhance the long-term performance of airfield infrastructure.